Okay.
Yeah, we have next week.
What's that?
She just asked when his birthday.
Yeah, 2 weeks. Okay, see, I put a reminder here for my son.
Perfect.
Yeah.
March.
Okay. All right, so what we're going to do today is we're going to graph some other sinusoids, okay? And we're going to see what they look like in polar form. So that's why for homework I asked you to watch that video that was reviewing graphs of things like a cosine x plus d and a sine x plus d and what those graphs look like. And then we're going to practice graphing things in Cartesian form, so we need to remember how to do that. And then we're going to see what these graphs are like in polar form, okay? So that's going to be what we're going to be doing for the next couple classes. So just for a quick review, right? So if you're asked to graph a cosine x plus d or a sine x plus d, you don't have this.
Oh.
Yeah, so you're just thinking, okay? So the absolute value of a, what does that tell you if you're graphing a sine or cosine graph?
The minimum, like the amplitude.
It tells you the amplitude, right? And from that, you're going to get the maximum and minimum. Exactly. So the absolute value of a is the amplitude. I said the absolute value because the amplitude's never negative, even though a can be negative. Okay, amplitude's a distance, so it's always going to be positive. Okay, D, what does D tell you if you're graphing something like that? What's that? The midline. Yeah, it tells you the midline.
Oh, I thought that was, okay.
Yeah, so you have this already. I just want to talk about it for a minute. Yeah, so y equals d is going to be the midline. And then the other thing you need to know is where you start these graphs, because once you know where to start, then they follow that nice pattern, right? And so if it's a sine graph, where's it going to start?
The midline.
At the midline. So this is going to start at the midline. And if it's a cosine graph, where will it start?
Either the minimum or the max.
Yeah, great. It's either going to start at the min or the max. And then how do we know if it's the min, a minimum, or the maximum?
If it's negative, if the amplitude is.
Well, the amplitude is never negative, but we can look at
Oh,
A.
but yeah, but if there's a negative, whatever the sign before A is.
Yeah, so A actually includes a negative sign, right? So if A is less than 0, then we have a minimum, and if A is greater than 0, then we're going to start at a maximum, right? And then the other thing we need to be concerned about with sine is that we start at the midline, but then we need to know if we go up, if we go from left to right, or if we go down, right? So for the midline, if A is greater than 0, which way do we start plotting our points? Up. So if A is greater than 0, we go up from left to right. And if A is less than 0, then you're going to go down. Okay? And we'll practice doing some graphs together as we move into the next
Can
thing.
I take a picture of this?
Sure. Yeah, or I can send this to you.
Oh,
I can send this to you after class. Okay, so what we're going to do today is we're going to graph things like a sine theta, a cosine theta, and a sine theta plus d and a cosine theta plus d. And you'll see these are just like the same things you were graphing, except you were graphing them in the Cartesian plane, and in the polar plane they're actually going to be some nice graphs. Okay? For homework, there's going to be 2 worksheets on Canvas. We'll see how far we get today. Hopefully we'll finish. These things are called limasones. Hopefully we'll finish that. If not, I'll finish it up with a video. And then the next thing you're going to review from last year is how do you graph sine and cosine if you have a change in the period. So the graphs that you did over the week always had a period of 2 pi, right? That's how long it takes to go around the unit circle, right? All those graphs had periods of 2 pi, but we can change that. So that's what you're going to review with a video. And then there's a worksheet with that. Okay, so I can send you guys this page, no problem. All right, so then we're going to go on to these notes, right? So we're going to graph basic sinusoids in polar form. So everyone has this, right? Yeah, okay, good. All right, so the first thing I want to graph is 6 sine x. Okay, so this is a pretty basic sine graph. So let's go through the analysis like I asked you to do with the video, okay? So what's the amplitude for this graph? 6. Yeah, the amplitude is 6. Great. What's the midline?
1.
The midline for this, what? 0, right? So D equals 0. So the midline is at y equals 0.
Wait, well, how do we know that it says 0?
Because there's nothing added here, right?
There's nothing, okay.
Yeah, so it's like plus 0, right? So it would normally be 6 sine x plus d. If we don't see anything, that means d is 0. So when I asked you to graph these, right, I asked you to make a little skeleton on your graph. Yeah, Aria.
If there was nothing before the 6, before the sign though, it would be 1.
Exactly, yes. Yeah, so if it just said sine x, then a is 1. Exactly. Yeah, good. Yeah, so because when we're multiplying, if nothing's there, then it's 1, right? Because 1 times sine x is still sine x. But if we're adding or subtracting, that number would be 0.
Okay, yeah.
Because if it were plus 1, then the d would be 1. Yes, you're right, and you're thinking about that. Okay, so if I want to go ahead and graph this, what should I do?
Draw a dotted line at 6 and negative 6.
Good. So I'm going to put, well, first I'm going to do the midline. That was implicit in what you said. Right, so this is y equals 0. That's our middle.
Because it was like, it already had a line from the x.
Yeah,
so
yeah. So I always start with the midline, right? And then you'll go up and down the amplitude from the midline. So I'm going to go up 6.
This is good review for the ACT.
Is this on there?
Yeah. I mean, usually it's like really simple questions about the amplitude.
But that's great, right? Because if you didn't remember sine and cosine, like those are ones you can get like that. Like you don't have to spend any time on it, right? It's great. Okay, so we make this little skeleton, right? And now I want to plot what 6 sine x looks like, right? So this is a sine graph. So I just need to know the starting point. Yeah, Aria.
Do you need to draw your lines? Or
You do not need to draw those lines, okay? I like to draw them because then I make sure I put the plot points on the right places and it just helps me frame it. But if it doesn't help, you do not need to do it, okay? Yeah. Okay, so where does this start? So that's the next thing I want to know. So what's my starting point?
At 0, 0.
It's 0, 0. This is a sine. Sine starts at the midline. So it's going to start at the midline. And starting means when y is 0. I mean when x is 0. So this is going to start at 0, 0. And then is this going to go up or down from there? Up, right, good. So a is greater than 0, so this is going to go up. And I always ask myself that question. I make sure because I may miss that it's a negative sign, right? So always make sure you ask yourself, which way does it go, right? And then once we know that their key points are every pi over 2 because that's 1/4 period. So I'm going to put 0, 0. Then my next key point is going to be at pi over 2, and that's going to be up at a maximum, right? Because we're at the midline. From the midline, we're going up, we're going to maximum. Yeah, Gabi, question.
Didn't you say that the amplitude has to be positive?
Yes, the amplitude is positive, but A is not the amplitude. A is this number. So here A is 6. The amplitude is the absolute value of A.
Oh, so for like the next one, so it had to be 7.
Yeah.
Gotcha.
Okay? Yeah. Good? Okay, so next key point is going to be at pi. So we're going to have pi 0, and then 3 pi over 2, negative 6, and then 2 pi 0. Okay? And then if we want to sketch this, we're going to make a nice graph. So I'm going to try to draw a nice sine graph. I'm going to put arrows at the ends showing that it continues on. Okay? So that's one cycle of the graph. So what we want to do now is we want to take this graph that we drew in the Cartesian plane and move it over to the polar plane. Okay? So the first thing we need to do is we need to figure out, we're going to label this in radians. So we need to figure out what all these angles are in radians. Okay? So we will get better at this as we do it over and over, right? So right here I'm going to be at 0 radians, right? If I go to the top, how many radians is that? Pi over 2, right? If I go halfway across, we're going to be at pi. Okay, we'll do the bottom, 3 pi over 2. Good. And now we want to do some of the ones in between, right? So we need to figure out how much each one of these lines is, okay? And the nice thing about this grid is each one of these lines on the Cartesian plane is the same amount of distance as these rays in the polar plane. Okay, so do you see how pi over 6 is 2 lines in?
Mm-hmm.
So this one, 2 lines up here, this is pi over 6. Okay, so this is a nice grid to help us move from one graph to the other.
Oh, so the pi over 3 is like the other 2 lines over.
Yes. So 2 lines over from pi over 6
But
is
don't
pi over
we-
3, and then I squeezed in pi over 4, okay?
Like, our points on the one on the left are only at 0, pi over.
Yeah, we only plotted those, but now we're gonna have to get some other ones.
Oh, okay.
Okay, it's not gonna be sufficient for this particular graph to figure out what it is with just those 4 points. So we are going to, actually, I've calculated what they are using a calculator. If we draw it really nicely, we can get some estimates from the graph. Okay, so let's go ahead, let's put these on. So pi over 6, the next one's gonna be pi over 4, then pi over 3. Then we're gonna skip up to pi over 2, and then 2 lines over from pi over 2 is gonna be 2 pi over 3, and then 3 pi over 4, and then 5 pi over 6. And let's see, are we gonna need all these? I think so. So I'll put these on too. So 2 more lines over is gonna be 7 pi over 6. So they're kind of little clusters of 3 that go together. 7 pi over 6. This guy's gonna be 5 pi over 4. And then 4 pi over 3. And then 3 pi over 2. And I'll do the last little cluster of 3. Everybody with me?
Mm-hmm.
Okay.
Wait,
Did I do it wrong? It's possible.
I thought every 2.
Every 2 is one of the ones that I wrote on here, except I added 3 pi over 4 and pi
Oh,
over
I
4.
just did it all wrong. I thought it was like every 2.
Every 2 is the ones that are marked in the Cartesian plane, but between pi over 6 and pi over 3, you gotta squeeze in the pi over 4 ones. Okay? Pi over 3, this is 7 pi over 4, and then 11 pi over 6.
So it's like 3 in a row.
3 in a row. Yeah, because remember how we had we had like 30, 45, 60.
Oh, yeah.
And then we had 120, 135, 150. And then there was a little space. Okay, everyone good with the grid, because we're going to be using this grid a lot. So I want to make sure it makes sense the first time, and then going forward, we won't spend as much time on it. Okay, terrific. So now what we want to do is we're going to start plotting points from the Cartesian grid to the polar grid. Okay, so I'm going to make sure that I've got these points pretty well. So pi over 4, so I didn't draw this so well. Pi over 6 should be at 3. I actually drew it pretty well. So pi over 6 is an exact point. That's 3, because sine of pi over 6 is 1/2. 1/2 times 6 is 3. Okay, and let's see. I'm going to give you a couple other nice points. Okay, so pi over 3, and you can estimate these from your graph too. Pi over 3 is 4.2, and, oh no, sorry, pi over 4. Sorry about that, wrong. Pi over 4 is 4.2, and pi over 3, if you look at your graph, what does your graph look like about?
Mine's at like.
It looks at 5.
Yeah, it's really a little over 5. So it's actually, if you calculate it, it'd be 5.2, but if you use 5, it'd be okay. Okay, so everyone with me, we're just estimating points. I actually calculated them so we can get a nice graph. Okay, so now what we're going to do is we're going to take these points from the Cartesian plane, we're going to put them on the polar plane, right? So when theta is 0, we're at 0, right? So 0, 0 is the pole, so we're going to plot that. We're going to plot 0, 0, right there. Actually, maybe I'll do a different color. I'll do it in red. Okay, the next point we're going to take pi over 6, 3, right? So we're going to go to the ray, we'll do each circle as 1, okay? We need to designate that. Okay, so pi over 6, 3. So I'm going to go on the pi over 6 ray. I'm going to count out 3 circles. I'm going to plot that point. Okay, next point we're going to get is pi over 4, 4.2. So go on the pi over 4 ray, go out 4 and a little bit to 4.2. Okay, stop me if it's not making sense, because we're going to be doing a bunch of these. Pi over 3, I'm going to go to 5.2. So 1, 2, 3, 4, 5.2.
How'd you get that?
From the graph,
As in just. Oh, okay.
right? It's pi.
Okay.
Yeah, so it's a little above 5 on the graph, and I actually put it in my calculator. But you could estimate it, right? This is 5,
But isn't it exactly at that point?
but my graph isn't perfect.
Oh.
So the real value is 5.2.
Gotcha.
My graph looks like 5, which actually I think that's not bad, that I had it relatively close.
Yeah.
Okay, then pi over 2, this is what Janie was saying, right? We only had these as exact points. Pi over 2 is 6, so I'm going to put that on there. 1, 2, 3, 4, 5, 6. Right? And now we can get these points over here, right? The points between pi over 2 and pi. What do you think about the points between pi over 2 and pi? Like if I picked 2 pi over 3, what do you think its value should be?
4.6.
No.
How do you think it should compare with pi over 3?
Well, should it be a little bit, it should be the same.
It should be the same, right? This should be symmetric.
So it would be 2 pi over 3.
Oh.
5.2.
Yeah, 2 pi over 3, 5.2.
I was just looking
Oh.
at the.
Oh, it's flying around.
I was
Okay.
just looking at your dot.
Yeah, don't, my graph isn't perfect, right? Okay, 1, 2, 3, 4, 5.2, right? What do you think about the next one, which would be 3 pi over 4? What should that be?
3 pi over 4, 4.2.
Exactly. So we should have 3 pi over 4, 4.2. Plot that. So 1, 2, 3, 4.2. And then 5 pi over 6, what should that be?
3.
That should be 3. Yeah, so mine's not so perfect. 5 pi over 6 should be a 3, so we'll plot that. 5 over 6, 1, 2, 3. And now we have enough. We're going to sketch this. What do you think this is?
A circle.
It's a circle! Isn't that nice? Right? And so now we have got a nice circle. Janie, you like it a little better now than
Yeah.
last. Okay, good. Okay, so this is a circle. So 6 sine theta is a nice circle. Okay, we're gonna do another one. Okay, what do you think negative 7 cosine x is gonna be?
A circle, but the other way.
Yeah, a circle. What do you mean by the other way?
Like, reflected downwards across the x-axis.
Okay, so let's see. Okay, some kind of circle. Let's see where it's gonna be. Okay, so we're gonna do the same thing, right? So we're gonna do this one a little bit faster. Okay, so I want to go ahead. I'm going to sketch this in the Cartesian plane. All right. So what's the midline?
1 or just 0.
0. Y equals 0, right? Because d equals 0, and the amplitude
7.
is 7. Right. The amplitude's positive, even though a is negative. What's the starting point going to be for this?
Negative 7.
Yeah, it's going to be a minimum, right? Because this is a reflected cosine. So it's going to start at a minimum, so it's going to be at 0, negative 7.
Wait, the minimum because it's negative?
Because this is negative.
Yeah.
Exactly. Okay, so cosine either starts at maximum or minimum. If we have a negative cosine, it's going to start at a minimum. So I'm going to draw in the lines. If you don't want to draw in the lines, that's fine. Okay, so I'm going to draw in the midline. Y equals 0. I'm going to draw in the maximum. Y equals 7. Skip pages. That's weird. Okay. And then we'll go ahead and we'll put in the key points, and then we will make a sketch that will help us get the other points. Y equals 7, and y equals negative 7. Okay, so it's going to start at a minimum, so at 0, negative 7, and if we start at a minimum, we can only go up from there. Right, and so we're going to be at pi over 2, 0, pi, 7, 3 pi over 2, 0, 2 pi, negative 7. Right, and now I'm going to try to sketch this as best I can. Okay. Put arrows on the ends because it continues. Okay, we're going to do the same process. So we're going to take these points from the Cartesian plane, we're going to put them in the polar plane. So I'm going to go ahead, I'm going to go around, I'm going to label all the angles like we did in the graph up above. So you do the same.
For the other one, like what would happen if you kept going? Because like you could keep the thing keep
Oh,
going.
if we kept going, what's going to happen is we're actually going to just keep tracing around this circle. That's a really great question. As we start doing the negative part, R is gonna be negative, so it's actually gonna be flipped back onto the same path.
Oh.
So we're just gonna keep going around and around the circle, so we don't need to do any more. But that's a great question, because it could be like make a figure eight kind of thing,
Yeah.
right? Okay, so I'm labeling all these. I didn't miss having to wear my mask for a couple weeks
I know.
when I was just inside my house all the time.
But you're always home when we're home.
Yeah.
Well, I stay home because I only have to teach for you, and then I don't teach for a little bit, then I drive in between. So yeah, I don't bother coming in just to. It's more comfortable at home. I have a better setup at home. Okay, so now we're gonna get some points. Okay, so I'm gonna put some points on here. So pi over 6 should actually be at -6. About. And pi over 4, when I did this,
Wait, really?
yes,
Pi over 6 should be at -6?
yes.
How do you know this?
You would put in your calculator, okay? Or you have to graph better than we did. That's why I put in the calculator. Oh, my pi over 3 is pretty good. Pi over 3 is at -3. Yeah, and that's gonna be enough for us. Okay, so now we're gonna take these points, we're gonna start plotting them, okay? So we're at 0, -6. Okay, so what does that mean? So Janie, I know you had some questions about the negative stuff when you're plotting the points, right? So 0, -6 means I really go out on the 0 ray, but since it's -6, I have to flip over 180 degrees, which means I'm actually going out on the ray that's at pi. Then I'm gonna count out 6 units. So 1, 2, 3, 4, 5, 6. Okay? Then the next one, we're at pi over 6. Oh, I'm going out 7 units. 1, 2, 3, 4, 5, 6, 7. So this is
Well,
-7.
you went at 7 units because.
Because it was 0, -7. 0. Then pi over 6, -6. So what that means is you're on the pi over 6 ray, but you need to go in the negative direction. So you're actually going to flip across the pole, which will put us on what ray?
The 7 pi over
7 pi over 6, and then count out six circles. 1, 2, 3, 4, 5, 6. Good? Okay, then we're at pi over 4, -4.9, so about 5. Okay, so pi over 4, we need to flip across the pole. What ray are we on? 5 pi over 4, good. So 1, 2, 3, 4, 5, so a little less than 5. Okay, then we're going to be at pi over 3, -3. That's actually an exact point, but pi over 3, -3, flip it over the pole. We're at 4 pi over 3. Okay, and then we're at pi over 2, 0. Okay, now these other points, the next set of points, where do you think they're going to lie?
It's gonna be like 5 pi over 6.
There's pi at 7 too.
Where's 5 pi over 6 going to be? What's it going to be like?
-3.
Would it be
5
6?
pi over 6 is going to be 6.
Oh, right.
They're gonna be symmetric over the line 0 equals pi. So 5 pi over 6 is gonna be a +6. So 5 pi over 6, +6, about. Alright? And then, I'm just gonna plot these other ones by symmetry. So it's at 5 pi over 4, I'm gonna go up to 3 pi over 4. I'm just gonna follow this circle around, so I get to 3 pi over 4, put it at 4.9. And then 2 pi over 3 is gonna be like the 4 pi over 3.
That's a 3,
So 2 pi over 3 is going to be like the 4 pi over 3, and that was at 3. That's the one that's exact. And now we can see our nice graph. Right? So this is also a circle. And if we continued on, if we did more points, we just start retracing the circle. Okay? So we have a circle, but this one is, I would say, more horizontal. It's on the horizontal axis as opposed to the previous one, which was vertical. Okay, so what we're going to do is we're going to take a look at Desmos. So I'm going to flip to the next page where it says, take a look at Desmos, and we're going to do a couple explorations. Okay, so I'm going to graph. Okay, so what are we supposed to explore? We're supposed to go to Desmos and try a cosine theta with different values of a, and a sine theta with different values of a. Okay, so what would you want to try? What should we try?
A positive it.
Okay.
Like a positive 7.
Oh, you know what I can do? I'll do this. So I'm going to put a slider, and now I've got a is 1, and I'm going to make a grow. So what happens is a is getting larger.
The circle gets bigger.
Yeah, the circle gets bigger. How does a relate to the circle?
It's the height.
It's a height, but when it's a circle, what do we call that?
The radius or the diameter?
Yeah.
It's the diameter, right? A is actually the diameter, right? So as I grow a, I'm growing the diameter. Now, let's see what happens when I make a negative. What do you think is going to happen before I do it?
It's gonna go to the opposite side.
It's going to go to the opposite side. So it used to be up, so now it's going to be down, right? It's just flipped. Nice, right?
So, but
We're gonna summarize this in a minute. Okay, so we're just thinking a little bit now, and then we'll come back and we'll fill in. Good? Okay, so sine, we had things that were vertical. Up when a was positive, down when a was negative. Okay, so now I'm going to switch this. So I'm going to make this cosine. What do you think is going to happen when I do cosine?
it's gonna go to the right.
It's going to go to the left or the right, right? Because cosine, remember, that was the x coordinate. It all kind of ties together, right? Cosine was the x coordinate on the unit circle. Y is the sine. So I'm going to start with positive values, right? So I'll start with positive a's. We've got circles on the right side. How does a correspond with a dimension of the circle?
It's
Flips it
still the
over.
diameter, but like horizontal.
Yeah, it's still the diameter, but it's going horizontally. And what do you think is going to happen when a is negative?
It flips to the left.
It's going to be on the left. Okay, so that's kind of nice, right? So now when we go forward, when we're graphing circles, we're not going to do all those points anymore. We're just going to know what it is. We're going to see what that graph is, and we're going to graph it. Okay, so we're going to summarize here, okay? So a cosine theta or r equals a sine theta are polar representations of circles, which is nice. Okay, how is the graph of r equals a cosine theta different from the graph of r equals a sine theta? So these are r equals a cosine theta. I would call them like our horizontal circles, meaning they lie on the diameter is on the x-axis. Right? Yeah. On the x-axis. And r equals a sine theta. Yeah, they're going to be, I'm going to just say vertical circles, even though that's not like technical, but we understand what that means, right? Our vertical circles. So that, by that we mean the diameter is on, well, I should say the center, right? Center is on the x-axis and center is on the y-axis. I think that's better. Okay, does that make sense? Okay, when a is a negative number, what effect does it have on the graph compared to when a is positive? So I'm going to split this into two things. So if we have r equals a cosine theta, so if a is positive, what happens? And if a is negative, what happens?
When A is positive, it goes to the right,
Good, so this is on the right,
and then negative is to the left.
great, right? So it's something like this, and here it's something like this. Okay, and we'll do the same thing. So if A is positive or A is negative. Okay, so r equals a sine theta. If A is positive, then it's going to be up. And A is negative, it's going to be
Down.
And then I'll make a little sketch so it's something like that. Or like that. Good? Okay, so the value of A is very easy to figure out. So what is A? or the absolute value of A tells us the diameter, right? So, and this is also going to be the maximum value on the polar graph. Okay, so now let's see what we understand, right? So we've got 4 graphs. We're going to write the equations for them. Okay? So this first guy, what do you think about this one?
Cosine.
It's going to be cosine. So this is to the right. And since it's right, it's going to be a positive cosine, right? So this is going to be positive cosine.
And the A is gonna be 10.
Terrific. And A is equal to 10, right? So that's the diameter. So we can write R equals
10 cosine theta.
terrific, 10 cosine theta. Nicely done.
Because the diameter is on the axis, there's no like plus D or anything.
Yeah, we're going to do those next. There's no plus anything. So the circles are just A cosine theta or A sine theta, no plus D. We're going to look at that next. What happens when you have this shift, just like we did with the Cartesian. Okay? All right, this next one, what do you think?
It's a negative sign.
Negative sign, terrific. So this is going to be negative sign because it goes down.
-3.
And
But A has doesn't A have to be 3?
A is going to be, the A is actually the value in the equation. This isn't the amplitude for the graph.
Okay.
Okay?
Okay.
So this is going to be R is equal to -3 sine theta because the diameter here is 3.
Yeah. So yeah, I thought your answer was A was in the
Yeah, so the diameter is 3, that's positive.
right.
A is actually going to be -3 in this context because we need it to be going down.
Gotcha.
Okay, next one. What do you think?
It's -5 cosine theta.
So it's going to be a negative cosine because it's left and 5 because that's the diameter. Good. So R equals -5 cosine theta. And the last one, you get in the hang of these.
0.5 sine theta.
Yes, 0.5 sine theta. Nice. Okay, so if you see an equation like that, the goal is, okay, recognize it's a circle and then you can graph it. Everyone feel happy? Excellent. Okay, we'll go on to the next thing. Okay, so the next thing is what happens, right, when we